So this is the interactive video number 6 for lesson task number 6, all about proofs. Now, thankfully, I've already done a problem with you guys in class, so you guys have an idea about what kind of proofs I'm looking for. So this is just going to be a recover of the notes, more so than anything. So let's just talk about proofs. Now, we're not going to do formal proofs or anything. It's going to be very informal, but it will still require you to have equivalency for each step of the directions. So the first thing is, how do we disprove? Disproving is pretty easy. Let's say I have sine of x plus cosine of x equals 1. This is not our identity. If it was sine squared x plus cosine squared x equals 1, then that is an identity. However, this is not. So what you need to do to disprove something is find a counterexample. What happens if I have x equals pi? Well, if x equals pi, I have 0 plus negative 1 equals 1. This is clearly a false statement. It is not true for all cases. So that's how we can disprove a statement. Find a counterexample. How do we prove things that are true, though? This is much more difficult. And the reason why it's much more difficult, instead of finding one particular, case, you need to make sure that the statement you hold is true for all cases. So not only do I have to make sure that x works for pi, x works for pi halves, x works for 0, whatever my proof required, it should be all the x values in general. And this is much harder than it sounds, but there are ways to actually deal with it. So my suggestion is look at one side first. Look at one side of the equation or whatnot of your proof and work on that. Maybe it might be the left-hand side. Maybe it might be the right-hand side. The next thing is you need to have all of your identities down packed. We're at the course in the game where I can't just have you guys write cosecant of theta equals 1 over, cosine of theta or sine of theta. It has to be the correct one. If I say secant theta, it should be 1 over cosine theta. If I say cosecant theta, it should be 1 over sine theta. You don't have that luxury in messing up definitions anymore. So make sure you have them down packed. And you have worked with definitions almost every single day. So I'm hoping that you took time to actually understood those definitions. You have your reciprocal identities, you have your Pythagorean identities, you have your co-function identities, you have your even and odd identities. A lot of you guys struggle with that, so I'm hoping that this will be the unit where we have that down packed. After that, you need to be able to simplify expressions. So let's say I have cosine of t plus tan t of sine of t. You need to be able to simplify this for me for all t element of real numbers. That just means all my angles, I'm accounting for every single angle possible. Well, the way you want to simplify things is break it down as much as possible. Cosine t and sine t are already broken down. However, in our reciprocal definition or identity, we can break up tan t as sine of t over cosine of t. In doing so, if I do that, I have this second expression over here. Now with this second expression, I can multiply the sine t times sine t. And I'm left with sine squared t plus cosine of t plus that cosine of t. Now you have a fraction. That means you got to get common denominator. So once you get common denominator, you have cosine squared t over cosine plus sine squared t over cosine t. Add them together, you just add the numerators, do not add the denominators. They have the same exact denominator. And then you invoke your Pythagorean identity for this piece right here. It's all about invoking the right properties and identities. And then that's equal to 1, so you have 1 over cosine t. Using your reciprocal identity, you can simplify that to secant of t. So that's a portion of playing proofs. You need to be able to simplify expressions. You need to be able to invoke your identities. And if you notice, you need to give me explanations at each individual step. Now, if you're just adding 5 plus 6 or whatever, you don't have to say that. But if it's an identity, then you must state it. If you're invoking the reciprocal, the Pythagorean, I will take off points if you do not. So be careful on that. All right, and this is another case of simplifying that's a very useful tool to use when doing proofs. And in this one right here, we notice that we have two fractions. We need to add them together. You got to be able to get common denominators. So that's what happens here, getting common denominators. Now, when I have common denominators, I can multiply the denominators out. I have 1 plus sine theta plus cosine theta. Notice I have brackets on here. You can use parentheses, brackets, but if I do not use parentheses or brackets, it is incorrect. You cannot write 1 plus sine cosine theta. That will be incorrect. You must say parentheses or brackets 1 plus sine theta, brackets times cosine theta. And then the question is, do you distribute that for the denominator? So I would refrain from distributing until you know you cannot cancel anything out. So leave the denominator alone until you've simplified your numerator. So in this case, the numerator is not simplified, so I'm going to apply the Pythagorean identity for sine squared theta plus cosine squared theta. I might have to invoke the commutative property if they were rearranged. But doing so, I have sine theta plus 1 over 1 plus sine theta plus cosine theta. And then that's where the cancellation happens because we're just multiplying at the end of the day. We have one giant term on top and one giant term on the denominator because they're all multiplication. The addition is part of a giant group, so it doesn't count as its own. And I can simplify this to 1 over cosine theta, and then you get secant theta, like the last problem, using the reciprocal identity. So, guidelines, they're all in your definitions. Be sure you check on that. My advice is work on one side, have the other side as a goal. Always refer to it. When you're lost, you know you need your problem to look exactly like your right hand side or maybe your left hand side. So use that as a tool. Next thing is, do not do this. Do not just square the right hand side and left hand side and then boom. You can't just square both of them and hope that works. Why? Well, because the square function, unfortunately, it's not a it's not a one-to-one function, which causes problems. So what I mean by that? Well, let's take the example, negative 5 equals 5. What happens if I square both sides? I get 25 equals 25. That's a true statement, but negative 5 does not equal positive 5. So you have to be careful on using that property right there. Be careful if you're trying to square both sides. I would much prefer if you invoke identities than working with both sides of the equation. Working with both sides of the equation requires precision. So here's an example of the first proof that we might work with. Now we're going to talk about cosine theta times secant theta minus cosine theta plus sine squared or equals sine squared theta. I'm going to work with the left-hand side. So what I like to do is the side that I'm working on or not working on, I like to write on the left. So this sine squared theta, I'm going to move that to the left side. Boom. Once I move it to the left side, I can fully work with the side I want to, which was the original left-hand side. And the reason why I want to work with the original left-hand side is because I can easily break it down. The sine squared theta, it's hard to manipulate that and guess what I have to do. But on the other side, if I just break it down, maybe things will play nicely. And that's exactly what happened. I'm going to distribute because this is multiplication. After I distribute, I can also use a reciprocal or identity and then, invoke some cancellation. So if you notice, I also wrote the distributive property. That's an important one. And then you have your Pythagorean identity, 1 minus cosine squared theta is equal to sine squared theta. And then you have a true statement, sine squared theta equals sine squared theta. I put a little box at the very end just to let me know that I finished the proof. That's how I normally do proofs. I just like to let the readers know that I finished it. All right, that's one part. Let's go to part 2. Let's do some more proofs. So we already did the first one over here. Let's move to this one over here. This is a very important skill that you'll need. So we have 2 tan t times secant t equals 1 minus sine t minus 1 over 1 plus sine of t. So this is subtraction. A lot of people struggle with subtraction with fractions. So you got to get the common denominator. Now, it's important because it's subtraction, you have to distribute that negative out. You have to. Don't make that mistake. Distribute that negative out, and then you have a new expression. Boom. Negative 1 plus sine of t is on your right side, or right side of the numerator, I'll say. And then you can combine like terms. 1 minus 1 is 0. Sine of t plus sine of t is 2 sine of t. Now notice my denominator, I did multiply it out. And the only reason why I multiplied my denominator, the least common denominator, is because the numerator did not cancel with anything on my denominator. The 2 side of t will not cancel anything, so I might as well go ahead and multiply my denominator, see if anything works out. And then, thankfully, I have 1 minus sine squared t. That's an identity, Pythagorean identity. So you can change that to cosine squared t. And then you can split this fraction up. This can be written as 2 sine of t over cosine of t times 1 over cosine of t, because there's 2 cosine of t multiplying at the denominator. Boom. And you can just rewrite that as 2 tan t times secant tan t, or secant t, and this is exactly what we have in our left hand side. So boom, that's another one. And then the next important one, we have 2 more important ones that I want to talk about before we end this video, is this problem right here. Cosine u over 1 minus sine of u equals secant u plus tan u. So I'm going to work with the left hand side. You can work with the right hand side, and you'll probably get the same. But I'm going to work with the left hand side just to show you a key trick that you might need. So the key trick that I'm going to show you is, notice that cosine of u over 1 minus sine of u, I cannot multiply both sides. I don't want to multiply both sides. You can, but I don't want to multiply because that's risky. A lot of things you have to account for. So I have to invoke some identity. The most common thing that people use in proofs in mathematics is the fact that you can add by 0 and you can multiply by 1. Now, when I say multiply by 1 and add by 0, it's not as obvious because there are different representation of doing that identity. So I'm going to actually multiply the expression by 1. 1 plus sine of u over 1 plus sine of u is equal to 1. However, this is similar to how we did conjugates. If you want to get rid of a complex conjugate, you're going to add or multiply whatever the binomial is, but instead turn adding into subtracting and subtracting to adding. And that is what I'm doing. I'm going to have 1 minus sine of u times 1 plus sine of u over 1 plus sine of u. That way, I can get a squared term out of that, and the middle terms cancel out. If I FOIL 1 plus 1 minus sine of u times 1 plus sine of u, practice your FOILing, it will cancel out and you're left with 1 minus sine squared u. Your numerator, you gotta distribute that, but it's fine. You can factor out or whatever. It plays out nicely. And then I can turn that to cosine squared of u because of the Pythagorean identity. So this is a very useful skill you'll need. And again, some of you might wonder, why didn't you just work with the secant u plus tan of u? You can. I'm just showing you this additional trick that can be in your arsenal. And then another important trick you can use, if you have more than one term on your numerator and you have a denominator, you can actually split up the fraction into 2 separate fractions or expressions. Notice that I can split this up because if I add the numerators here, cosine u plus cosine u sine of u, they have the same denominator, so technically these are equivalent. We're just working backwards now. It's like partial fraction decomposition, but easier. So that's a skill you'll need to use as well, being able to have a fraction and split up the numerator if there's more than one term. Don't get it twisted though, you can't do it if the denominator has more than 2 terms, and you can't, or if the denominator has more than 1 term on the denominator, you can't split up the denominator. You can split up the numerator, but not the denominator. And if you're unsure, try to go back. Try to see if I add these together, will I get this piece? If you are unsure. Don't make the assumption that it'll always work. And then I can simplify this, cancel out the cosines of u's and whatnot, and then I get the property or identity or the proof. Secant of u plus tangent u. And then, I state the explanation, the reciprocal identity, Pythagorean identity, all of that. So you need to do that. And the last thing we'll look at, the most important one for people who are going into calculus per se, is over here, trig substitution. So I want to substitute sine theta for x in, that means in, square root 1 minus x squared. And I want to simplify it. Now, assume that your angle measurement lives in between 0 to pi halves. So if we assume that, all I am doing is substituting sine theta for x. Just plug it in. Now, I have square root of 1 minus sine theta squared. You got to take it step by step. Don't jump the gun. Don't immediately square it. Write out the expression first. And then square the value. And then you have the Pythagorean identity, which is square root of cosine squared theta. Now, when you're square rooting something that's squared, you got to be careful. You might have two solutions. You might have two. So your result is positive at the end of the day. It'll always be positive, only because your square root is assumed to be positive. However, you could have a negative or positive angle or cosine theta originally. So you have to be careful on that. So the only reason why it's cosine theta is because our angle measurement lives in the first quadrant. However, if the angle did not live in the first quadrant, you might have to say that you have the absolute value of cosine theta. And the example I give is, let's say you're square rooting x squared. Well, what if x was negative 5? If x was negative 5, that means when I square root it, I still get 5 as an answer, but 5 is not equal to negative 5. So I have to say this is or the absolute value of x if my theta did not live in that region. So boom. So you got to be careful with that. That's precision I will require. So that's the idea for the main parts of the proofs. And I'm hoping that you look at the guidelines, you practice these problems. There's a lot of homework for homework number, I believe it's 6 or 7. There's a lot of homework for that, so you can have additional practice before the upcoming midterm. So be sure you're on the lookout for that. I will catch you guys later. Take care. Bye.